Hello, I'm James Reba with the Vsbs Resistor Group. Today we're going to show the improved RTC performance of the Wsbs 8518-35 battery shunt resistor. The equipment that will be used today, the first piece of equipment is the bridge, which will take the resistance reading of the component. On top of that is a temperature gauge, which will let us know the temperature of the resistive element for each of the components. We then have two fixtures. One fixture has the Wsbs 8518-35 with the nickel chrome alloy, and the other fixture has our standard Wsbs 8518 100 microhm with the manganese alloy that we're comparing it to. And then on the computer screen we will show the results of all of the readings at room temperature, cold and hot temperatures, and then compare the two. The first device we're going to test is a Wsbs 8518 standard component. It's 100 microhm and uses a manganese alloy. There's a thermocouple attached to the bottom of the resistor to determine the temperature of the resistive element, and then it's connected to the bridge to take the resistance reading. The Wsbs 8518-35 resistor has both nickel chrome resistance alloy. It has a patented boot design and calibration cut. All of this combined helps improve the RTC performance of the resistor. Our standard component is 175 ppm. This improved design is less than 65 ppm. The initial room temperature is 22.5 degrees Celsius, and the reading at that temperature is 103.65 microhms. To chart the resistance readings, we first clear out the data. And now when I hit run, this will be for the standard Wsbs 8518. At room temperature, it's reading 103.65 microhms, and you can see on the chart it's charting the resistance value reading. To first prove the RTC performance, we're going to do a test at around negative 20 degrees C. So I will hit the Wsbs 8518 with cold spray till it gets the resistive element temperature to minus 20 degrees C. So now it's at that temperature, we will run the test and it'll chart the resistance reading, which is about 103.1 degrees. Okay, now that the resistor has met temperature of negative 20 degrees C, we hit the run button and it read the resistance value was around 103.1 microhms, and you can see the chart and the change of resistance here. Okay, now that we cooled it down, we're going to heat it up to around 70 degrees C with the heat gun. So we'll continue to heat it until it gets to 70 degrees C element temperature. Okay, now that it is at 70 degrees C, we will run. It'll take the resistance value. It's now at about 104.06. So we'll take a stop on that reading. So now you can see the full range from cold to hot temperature for the standard Wsbs 8518 manganese alloy element. Now that we've tested the standard component, we've hooked up the Wsbs 8518-35, and we are going to take a resistance reading at room temperature. So when we hit run, it is reading around 99.95 microhms. Now that we've taken the room temperature reading, we're going to hit the component with cold spray to get the resistive element down to minus 20 degrees C. And once we've done that, we will take the resistance value reading, which is around 99.91 microhms. And so I've hit stop, so it's charted the difference. So you can see the standard component, cold temperature, had a much larger shift than our new product for cold temperature. Now that we've taken the cold temperature, we will heat the component up until the resistive element is to 70 degrees C. Now that the resistive element is to 70 degrees C, we will hit run to get the resistance value, and then we'll hit stop. So now you've got the comparison of both the cold and hot temperatures. You can see the standard component has a much greater shift than the Wsbs 8518-35. The main application for battery shunt resistor is in battery management and automotive applications. In automotive under the hood conditions, you have very large extremes in cold and high temperatures, and the designer has to account for a shift in resistance due to these high temperatures. By utilizing the Wsbs 8518-35 resistor, the designer does not have to worry about extreme shifts in resistance over that temperature range.